Hey everyone, it'll be a while until we get started, just letting people join. And yeah, once we have enough people, we'll go ahead. All right, so hey everyone, we're still waiting for the previous workshop to finish up, so we'll be waiting until 8:10 to start. Just a heads up. All right. Hey everyone. It's 8:10, so we will be starting our workshop. So in case you guys aren't aware, like especially to the freshmen here, um, this is a thing called Berkeley time where classes just start 10 minutes late and it's supposed to give people time to like go from class to class, but obviously things are different now with Zoom classes. But still, Um, yeah, we're following Berkeley time, and we'll be starting our workshop now. So, hi everyone, I'm Shaunak Bhandarkar. I'm the Curriculum Officer for PlexTech, and let's get started. So this workshop is going to be part of it, like a very small part of it will be based on this presentation, and most of it will be through a live demo, and you guys will be able to follow along. So I'll explain that going forward. But just first, um, just a quick heads up, this workshop is going to be mostly focused on fundamentals of these data analysis tools, such as Pandas and Matplotlib. So I'm sure some of you will have experience with that, and that's awesome. This workshop will be more of like a cool application of those skills. But again, like it's totally fine to not know these. Like we don't expect you to know any of these. We're going to be teaching the basics like completely from the start. So don't worry. It should be a fun experience either way. But yeah, we're trying to specifically target this towards the theme of social justice, like the rest of the hackathon. So before we get started, I'm going to send out the link to these slides in the chat. So these slides themselves shouldn't be like, you probably won't need to follow along during the presentation. It's more for reference for later if you ever decide to look back at it. But what will be really helpful for following along, um, sorry, I'm going to be sending out another link, which is part of these slides, but I'll just send it out separately. It's for the Jupyter Notebook, and I'll explain more about what that is later. But basically, this will let you run the code, which we're going to be doing like on your own browser. Like it's just browser based. So if you go on that link, that will be helpful for following along. And let me know if anything isn't working, either the links or like if you have any questions, just feel free to just enter it in the chat. So all right, let's get started. So data analysis and visualization is a pretty popular field right now because it leads into kind of, it's kind of like a segue into like the highly popular fields of machine learning and it's like, it is data science, I mean. So these are pretty popular fundamental tools that we'll be learning today. And here are the three main ones. They're for Python. Um, Also, you guys don't need to know Python to do this either. It's just we are going to be going over the like basics for the specific example. So yeah, don't worry if you don't know any of this. So some of these key tools for Python are Pandas, Numpy, and Matplotlib. So Pandas is the main tool for allowing you to work with data frames. And what data frames are they're basically just tables of data, like 2D tables with rows and columns. And the data can be of any form, like mainly just numbers or strings or booleans, like true or false. But yeah, so you can think of a Pandas data frame as like a table, and Pandas gives you many tools for cleaning, filtering, and aggregating the data, kind of like reforming, like reformatting the data, doing like applying functions to it, basically just modifying it in any way, modifying, sorting, that kind of stuff. And NumPy, on the other hand, is another tool meant for creating and working with like different forms of arrays, and it gives you different tools. Like for example, um, it if you guys have any experience with linear algebra, NumPy is helpful for modeling and storing vectors and matrices. So NumPy is not something we'll be using as much in this workshop, but it is like pretty helpful and popular skill, and it's helpful overall. And then finally, this is actually a main part of this workshop is Matplotlib, and it's the bread and butter of visualization in Python. So it's the basic plotting library, but it's very versatile in the different kinds of graphs and charts you can make. And I'm going to be, in this workshop, I'm going to be showing a couple of pretty simple visualizations towards the end of the workshop, but feel free that this is mostly due to time constraints, and there's actually, you can go very advanced with these visualizations. So, in addition to Matplotlib, there's some additional plotting libraries in Python that are helpful, and there's some trade-offs between all of them, but they some are more helpful depending on what you need to plot, what you need to use it for. So here's just a comparison between 3 of such plotting libraries. So first is Matplotlib, which I just talked about. It's the basic plotting library, and it's very customizable because all these other plotting libraries are built off of Matplotlib. So basically everything you do with the other libraries is it's doing a lot of the work in the background, which you would have to do in Matplotlib otherwise. So one of the examples is Seaborn, which gives you more variety for the graphs. It's like you can see these 3 on the top, those are from Seaborn, and there's generally better graphics from Matplotlib. And one of the advantages is that it's good at integrating with pandas, which is again what you use to store and work with your data. Finally, a third one is Plotly, which also has a lot of variety, just like Seaborn. And one thing it has in addition is good support for 3D visualizations, which again, we won't be looking at in this workshop, but it can be a very interesting field, very interesting topic to dive into. And also it has well integrated zoom and pan features. So instead of the visualization just being a static image, you can kind of move it around and look at it that way. And finally, it also has a nicer way of exporting the images. It's just a more streamlined process. Again, we're going to be focusing on Matplotlib in this workshop. So our example here, which we're going to run through, is specifically for social justice related issues. So I highly encourage you guys to follow along. So click the link which I sent out in the chat. It's the same as this link for the Jupyter Notebook. And I can actually show it right now. I'll go on there myself. It'll take a while to load. All right, so this is basically everything we're going to be running through today. Don't worry about looking at it right now. We'll be going through it slowly. But what a Jupyter Notebook does, which is really cool, is it allows you to run this code on the browser itself. And you can do that by clicking on the code box and either pressing play over here to run the cell or pressing shift enter. And as you can see, shift enter runs the code, and it allows you to skip ahead to the next cell over here. So if you just keep pressing shift enter, you'll go through the whole thing. Now, is everyone able to edit this locally if you could? I'm not sure about that. I'll send the link again one more time in the chat for everyone who just joined. Okay, awesome. So if it lets you edit, you'd be able to make your own changes as you go along and then run that and see the edits as you make it. So one thing is I'm going to be going through the whole process of downloading and looking through the like finding a data set and downloading it and working with it. But when you guys are on Jupyter Notebook, you shouldn't need to do that because I've already uploaded the data sets we'll be using to the kind of file directory that it stores in the background. So, oh wait, I'm seeing that there's a file not found error. Is everyone getting that? Oh, okay. All right, so then you guys might have to follow through with the whole process of downloading all the data again. And that's fine because I'll be going through that for about the next few minutes. So yeah, just try to follow through with me. Sorry it's not as convenient as I was hoping, but it should be fine. Okay, so back to the presentation. So the next step is finding a relevant data set. So one website that's really useful for government data is data.gov. And I mean, that's when I was creating the whole plan for this workshop. I'll just run you through what I did. So I went on this website, data.gov, and please try to follow through. Especially if to get the Jupyter Notebook to work. So data.gov has just all sorts of government data, and what so I will just show you guys the specific one which I chose. So I went to it says over here get started, and there's a search bar. I didn't put anything in the search bar, I just clicked on it, press enter. So now out of all these data sets, I went to topics and I chose finance. Thought there would be some good data there related to social justice. And the one which I found was on page 4. So if you go down and go to page 4 here, it's called Housing Problems of Low-Income Households. So everyone, Yeah, this is how you find the data set. I can send this link again too. That's fine. All right, so I sent the link. Oh, and if you see what Akshat's sending in the chat is, if you don't want to use Jupyter Notebook and you want to run Pandas and Matplotlib locally, that's fine. That's actually great if you want to, like if you plan to use it later on. But I think for now, Jupyter Notebooks is a convenient solution if you're able to get it to work. So once we're on here, on the specific dataset page on data.gov, go to downloads and resources. You see it says XLS here, so it's in the form of an Excel spreadsheet. And this is the kind of data we want because we want it to be in like a table format so that you can use it with Pandas, because Pandas also works with data frames, which are like a table format. So if you click download, it takes you to this other this other website for the Department of Housing and Urban Development. And if you scroll down here and click data, this is where you download it. So this is the one which I chose. It's the default 2012 to 2016 ACS 5-year average data. And whereas for geographic summary level, select counties and select file type as CSV. And now just click download and it will download it as a zip file. So if anybody is having trouble, please say this in the chat. I'll just give everyone a bit of time to download the zip file. All right, can anyone, okay, so if you guys need more time to do this, could you raise your hand with the raise hand feature in like through Zoom? Otherwise we can move on. All right, looks like we can move on now. So once we have this zip file, if you open it up, you can see there's this folder. There's another folder called 050. And inside here, you have a bunch of different Excel spreadsheets. This is a lot of data. So what you guys should do is then extract all to a folder. And now you'll have your extracted data. So now if we just open up any of these tables, let's say table 1, for example, you'll see a bunch of stuff that makes not much sense. Like you can see the county names here, but oh, all right. Wait, are you guys able to see my screen? I think there might be an issue with that. Oh, okay. Yeah, sorry about that. Here, sharing my whole screen now. Yeah, all right, my bad. So now can you guys see it? All right. And did everyone see how like we got to this from extracting the downloaded zip file and then opening it up and seeing all, oh yeah, sure. So this opened up as, so did you guys saw how I downloaded the file, right? All right, cool. So after downloading it, I just opened up the zip file and I pressed extract all, and then from extracting all, it opened up into this folder, and now I selected here, and now I saw all of these Excel spreadsheets here. So from there, I just selected table 1 because, like, just as an example. So in table 1 over here, you can see all of these column names, which don't really make sense, and you see all these numbers. So it might be confusing. So what you guys should do is, usually they wouldn't just leave you in such a confusing situation. Like, that's not really fair to anyone, right? So what they do in these data sets is they have a special spreadsheet which explains what all of these column names are. So let me open that up again. And also thank you guys for helping each other in the chat. That's very helpful. So thank you. Great job. So anyways, this file is the data dictionary, which tells you what all the column titles mean. So over here, you can see in table 1, it has all of these. These are the column names from earlier, which didn't really make any sense. And over here, it explains what all of these correspond to. So what this data is it's basically from a survey of people, either who own apartments and houses or renters, and it tells you whether those people faced one or more of 4 possible housing problems. So what they define as these housing problems are whether the house lacks kitchen or plumbing, whether it's very crowded, too expensive, or oh yeah, so 2 of those are lacks kitchen, then lacks plumbing, and then too crowded and too expensive. So what we're trying to do with this example is we're trying to show how we're trying to see whether there's a like kind of association between race and ethnicity and whether people face these housing problems. So these are just all the different variables that that you could use. It's just basically what all the data corresponds to. But anyways, to use our Jupyter Notebook, what you guys should do is, let me go back to that window. So go to Files on the left and click this Upload to Session Storage button and select all of these files and press Open. I'm not going to do it because I already have them all here. So why don't you guys just upload all these files to your session storage, and let me know if you guys have any trouble with that. It'll probably take a while because it's just such a big amount of data. Hopefully it takes no more than like a minute or two though. All right, so great question. When it says this runtime will be recycled, that means that after an hour or two, this Jupyter Notebook times out. So when it times out, all that happens is like you'll still be able to access this link and this whole, like everything you see on the right, the whole notebook part, that will still be there. It will just delete all the data that you're uploading right now. Like all these files will be deleted from the Jupyter Notebook itself. But as long as you have the files stored locally, if you ever want to go back to it, you can just upload it the same way you're doing right now and just use it again. Yeah, no problem. Okay, so Brian, to, oh, okay, so now my runtime disconnected. That's what happened. That's what happens like after an hour or so after you open it. So this should be a good example. I'll just show you how to upload it again. Oh, never mind. It looks like my data is still there. It gets recycled sometime. But to open it, you would click the Files tab on the left, and this Upload to Session Storage tab. This button up here. Okay, yeah, we are just going to be using table 1 in this case. So that's all we really need. Yeah. So yeah, just upload table 1 if that's all you want. I just give the example of uploading all of them if for some reason you want to change, like modify, like play around with something else, but you don't need anything other than table 1. Yeah. So once you guys have that uploaded, you should try this first code cell. Just click run or shift enter and check whether it shows all the data up here. If it doesn't, let me know and we can work around that. But this is what it should be doing. So does anyone need more time for uploading the data? So okay, let me send out the link one more time. Sorry about that. Are you getting are you guys saying you're getting the error? Is this after you have uploaded table1.csv? Oh, okay. All right, let me see what we can do about that. Oh, 1 second. Let me just stop sharing. All right, so I open it up on another window. I'm going to try uploading it again. So just table 1. Right here it is, table1.csv. Yeah, it's working for me. I guess if it doesn't work, you guys can just watch along, because I'm going to be running the same code, and then yeah, you guys can just watch for now. I'm sorry, if it doesn't work, but later if it doesn't work, then I don't know, you can, and like you still want to try it out, then you can message me afterwards and then we can try to figure it out. But for now, I'm just going to run through everything. We're a bit short on time. So what these 3 first lines are import statements, and that's basically telling your Python program that you want to use these specific libraries. So the 3 libraries are, again, Pandas, Numpy, and Matplotlib. And where you see as here, that means like we're saying that every time we want to use Pandas, we can just abbreviate it as PD. So this is basically, over here, you can see this is the read CSV method from Pandas. PD is just you're just abbreviating Pandas as PD. And so first, this is how you import it. Like, you tell your program that you want to use it. And now we want to set our data frame to what we're reading from table 1. So that's what this read CSV function does. Pretty simple, is that it converts the CSV file, which is the Excel spreadsheet, as into a Pandas data frame. And this encoding thing, you don't really have to worry about it, because encoding is just like a way that like the data is stored, like the text is stored. And by default, there's an encoding called UTF-8. And usually what you will use, usually a lot of CSV files will use UTF-8. Only this specific one, which a specific file that we have over here, uses this kind of encoding called ISO 88591. So just once, if you didn't have this in this case, it would give you an error, but this should work fine. So basically now you have read the CSV file as a Pandas data frame, and you can see here that it's just this massive file, as you could also see from Excel. So you can scroll through it from left to right and up to down. when it's displaying it, it doesn't show all of them. It just shows this dot 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 in between, because otherwise it would be 3,220 rows. That's a lot. But anyway, you have this giant data frame here. And again, sorry, I'm gonna have to go quickly because we don't have too much time left. But over here now, what we want to do is select the specific columns we want. So if you go back to the dictionary file, what we want to do here is we want to select the group of renters that have one or four of these housing problems, and we want to standardize the income. So let's just say this greater than 100% of HAMFI, and what that means is they have at least the median household income. And basically what we want to see is whether there's any impact on race with all these other factors considered. So I scrolled through this file of definitions and saw the names of the columns that we need. So we want renter occupied has one or more of the four housing problems, greater than 100% of income. And now we want to see among all the race categories that they have here. So these columns that we want are 161 to 167. So what we do over here is we select from the data frame, we want the name. So the name is just the name of the county. We want that data. And we also want the data for these 7 columns. So what you do here is you need these 2 sets of brackets. So inside the inner set of brackets, this is basically just a list of column names. So what this does is it selects a subset of this big data frame, which only includes the columns that we want. And after you do that, we want to rename the columns. So we want to rename the column by this name to white, because we're just standardizing all the other factors. The only factor we're dealing with is race. So we're just going to rename all of these column names to the races that they're associated with, which again you can check in this dictionary file. And what this uses is the rename function and this data structure called a dictionary, which is basically it maps from a key to the value. So the key is the old column name and the value is the new column name. And what in place equals true does is it modifies this new data frame we created called problems. It just modifies problems itself instead of creating a copy of problems. So if you say shift enter, it will give you a little warning here, but that doesn't really matter. It'll still work. And now you can see it only selected these 8 columns. All the other columns are not here anymore, and they have the names that you want. The rows are still all the same. It's all the counties in America. And now, just real quick, this is the same thing we do here with a different set of columns. And these columns, we want to be same factors, like same race, income, and renter occupied, except the only difference is that we want these to be the number of people without any of the housing problems. So basically these are the people not affected by the problem we're trying to research here. So we do the same thing here. No problems in the same way. It shows you the numbers of people of each race which don't have those problems. And now what we're going to be doing is aggregating the data from all the counties. So basically, that's just a fancy way of saying we're just trying to find a sum of the entire column. So instead of looking at these individual counties, we want to just find the sum of the number of white people in the whole country um, who face problems with their housing, and the number of black people. Like for each race, we want to find a sum. So what that does is like all you have to do is you create a new variable called problem totals, and you just set this equal to problems.sum. And now we want to delete the value called name, because you can't sum names. Like this is just a bunch of strings. We're only interested in the summing the numbers together. So we delete that, and now if you run this, we end up with this over here. So this is something similar to a data frame. It's actually a Pandas series. And what a series is it's just basically like equivalent to a column in a data frame. All it has is an index on the left and then values on the right. So this is just very simple. This is just a sum for each race. These are all the people who faced housing problems. And similarly over here, we have sums of all the people who didn't face housing problems. Now what we want to do is to be able to effectively compare between these categories, which are of different sizes, the race categories, we want to be able to find a ratio of like how many people faced problems over the total number of people surveyed. So what we do over here, this seems like a simple math operation where we're saying ratios equals problem totals divided by the sum of problem totals and no problem totals. Except like this would make sense if you're working with just a variable, like if each of these corresponded to one number. But the thing is that each of these actually correspond to a column, like a list of 7 numbers here. So what we're doing here is actually something really cool that Pandas allows us to do, is that what it does is for each row, so like this value here, it will say 594938 divided by the sum of this and this. So it runs that operation for everything in each of the first 2 columns. And then similarly, it runs the same operation for everything in the next 2 columns, the next column of each of these series. So what you end up with is another series which is equal to like this calculation, this like row-wise calculation. And that's what you get here, proportions by race. All right, we're gonna have to hurry up again really quickly. So now another thing we can do here is, let's say you didn't want to look at the sums for the whole country. Let's say you wanted to select a specific row. So what we're doing here is we're looking up a specific row for Alameda County. This is one thing that Pandas allows you to do, is it looks up in the problems data frame. It selects all the ones with the name that contains Alameda County. And there's only one Alameda County in the country. So you only end up with this one row. Similarly, you do the same thing for those with no problem. And so now you'll see a difference here is that this is one row, when meanwhile here for the sums, it was a column. So what we want to do is use this method called squeeze to reformat it into a column. And after you do that, you want to again delete the names, because like the name doesn't matter. Like we already know that there's only one name, Alameda County. So we're deleting the names. And now again, we calculate the ratio the same way for each of the races in Alameda County. So now this is basically what we're going to cover for Pandas. Now let's move into Matplotlib, which is how we're going to do the graphing. Okay, so great question, asking what the squeeze function does. is basically earlier you have this row over here, and now after we call the squeeze function, if you want to show what Alameda this Alameda problems is, it reformats this row as a column. So all these column titles that were here earlier became like names of the indices, and all these values that correspond to the column titles, these values now became they became the values in the column. Basically, it's just for changing the shape. Yeah. So now, this is an example with Matplotlib. We're going to be creating a bar chart. So, like as you can see this bar chart over here. I'll just run through really quickly what we're doing here. So when we're saying enumerate, like all of this is just a fancy way of saying that for the x-axis, we want to have 7 values. So this should basically, even though we assign the names for those later, we can just think of this as 0, 1, 2, 3, 4, 5, 6, just like an index of a list in Python. So this x position array is just, it's just a list of 7 values. And now we say we want to create a bar chart, which takes the values from the ratios this Pandas series over here. So what Matplotlib does is it uses a NumPy array, which although we're not using NumPy, it's basically useful for making arrays, but a Pandas series behaves very similarly to an array. So we can also input a Pandas series or even just a Python list. So anyway, over here, we're setting the X label to race, the Y label to percent of renters. This is the titles. And now X ticks. This is where we say what we want these names to be. Oh yeah, you're right. It should be fraction of, not percent. Yeah, good catch. This is not a percent. This is just like a fraction of the whole. I could just, yeah, thanks, good catch. So over here for ticks, we're giving what we want these titles to be for each of these bars. So we're saying ratios.index. And what ratios.index corresponds to is, if you go to ratios over here, this part on the left is called the index, and on the right is the values. So over here we say that we want what we want these titles equal to be. And tight layout is just a way to make sure that everything's showing and not like doesn't get cut off or anything. So then plt.show is how you show this graph. Now similarly, real quick, I'm going to show an example of a stacked bar chart. So this is useful if you want to not only know the proportion, but also like the total number, because just like demographically, you can see that from the people they surveyed, it was a lot of white people, and you can see all these different proportions is found. But over here on the left side, this is in millions. It's showing how many, like the number of renters, and now you can see how many of them had at least one housing problem and how many had no housing problems. So how we're creating this is very similar to the earlier bar chart. Just over here, we call this bar function twice. So one of these is for creating the red. So just imagine you didn't have this first part for the green. This would just be a bar chart which shows how many people faced at least one housing problem. But however, we also, and like we say that it's red by saying setting color equals red here. But we also want to show the green, which is how many people faced no housing problems. So it's basically the same thing, except there's one extra variable called bottom. And over here we say bottom equals problem totals. So what that is we just want to show how much space off the bottom that the second bar, the green bar, should be. So imagine if the red wasn't there, the green would just be floating like above this axis. And we want the space that it's floating to be equal to how tall the red bar is. But yeah, besides that, this is the same as the previous bar chart. One more thing is there's a legend that we added to the side. Yeah, you can see how to do this here in this example. And now, finally, really quickly before we wrap things up, I'm going to go through an example for a histogram. So let's say, so earlier we showed how we can select just one row for Alameda County. But let's say we wanted to select just one column. So let's say we wanted to see the data for all Asian people, for example, across the country. But we wanted to see for each county how many Asian people face these problems. So over here, you would select a column by saying problems and then in brackets, the name of the column, which is Asian. So first we're selecting it from this this data frame called problems, which from earlier, if you scroll up, was just by race, the number of people in each county who faced housing problems. And similarly, we have another data frame for another series actually for the number of Asian people in each county who faced no problems. So now what we want to do is we want to change the index. So let's just say we got rid of this and Asian problems. We wanted to show what we have here. The index is just this number corresponding to each county, but we don't want to see the number. We want to see the name of the county. So now here we set the index equal to the name corresponding to each of them. So if you see here, you have the name and then the number of Asian people face problems. You see a lot of zeros here. You can just infer that they didn't find any Asians to survey in any of these counties listed here. But now we do the same thing with calculating the ratios. You see the number of people with problems and you divide it by the total. And now let's just ignore this last line. So now you see all these NaNs, which means not a number. In this case, what this means is that we're trying to divide 0 by 0. Because if you divide 0 by 0, you can't do that calculation. So what we want to do is replace all of those NaNs with zeros. Because if there's 0 Asian people after all, like, then none of them are facing problems. So now we filled all of those, and now we have the complete data that we need to make a histogram. So making a histogram is pretty simple in Matplotlib. It's just this hist function, and this is the data, Asian ratios, and we tell how many bins we want. So you can see here 1, 2, 3, 4, 5, 6, 7, 8. Then we just say the color and alpha level. That's just for extra styling to make it like a lighter color, more transparent. But now over here, we just give the title, the X label, and the Y label, and then you show it. So what this histogram is created is based on the proportion of Asian renters that face problems. Most of them, you can see that in most of these counties, this number was between 0 and I believe 0.125 because there's 8 bins. So yeah, this is just how you make a histogram in Matplotlib. And this is all for right now. Sorry that this workshop was a bit slow in the beginning and hurried up. But if you have any more questions, feel free to message me or email me or anything. And yeah, you guys will have access to these, to this Jupyter Notebook and this data set. So I hope you guys are able to, in your own time, like if this didn't work for you here, I hope you guys are able to run this locally and somehow get it to work. But I guess, um, yeah, just to wrap things up, this was just an example on how you can find a data set, like a government data set, because usually those will be the most relevant to social justice issues, and how you can kind of analyze the data, select the data you want, and then kind of use it in your own way to create these graphs. All right, so yeah, thank you. Thanks all you guys for coming to the demo, and I highly recommend you guys come to the social workshop that's coming up next. And it's exciting. It's exciting to have all you guys here at PlexHacks. So thank you all, and bye.